Hello, everyone. Thanks for joining our Mirantis Tech Talk around secret management using HashiCorp Vault and the new secrets operator, which is currently in beta. So pretty excited about that, right? So who am I? My name is Martin Nirtl. I'm a solution architect from Mirantis. I work for Mirantis and I'm originally from Austria, live close to the capital city, Vienna. And yeah, my interests are all around Kubernetes. And with that, let's have a quick look on what we will cover today. So today, I'm going to talk a bit about secret management, then about Kubernetes secrets. We talk about challenges and considerations when it comes to secret management. So what are the pitfalls, for example? Then I'll talk a bit about HashiCorp Vault and how it tackles that space. And later on, we will have a demo how to explore Vault, like not how to explore Vault, but we will explore Vault a bit together. And then we will focus on the secret operator and how to retrieve a secret in a kind of simple demo, but also I will show you on what you need to pay attention to when you consume secrets in Kubernetes. So yeah, secret management. Let's have a look on what exactly that is. So secret management, quite simple. I try to really keep it simple because I think it's not. It makes not too much sense to go into too deep into that. So what's the definition from my point of view? It's a way to securely store, access, and manage sensitive information like passwords and other stuff. We want to maybe distribute it, but for sure we want to protect it from unauthorized access, misuse, or exposure. So we don't want to have our credentials being leaked on GitHub or on Twitter even. I don't know. So that Elon Musk is hacking us. So this is what we definitely don't want. And what we can derive from that is some key points that we would like to see in such a system in a secret management tool. And this is definitely having a secret storage, right? Maybe some encryption underneath where we can put our secrets so it can't be read easily. We want to have access control, so to control who has access to it, secure transmission for distributing our secrets to our consumers, rotation and expiration, kind of more advanced concepts. For example, rotating my database credentials because data, after all, is typically the stake that we or any company has. And it's really like, I think, most importantly, to really protect it well. We also should have auditing and monitoring tooling kind of available in order to also, of course, assess what's going on in our secret management tool. And nice to have is definitely also automation of any kind, right? Be it maybe Terraform that we use for feeding things into our Vault, but also, now I said Vault already, in our secret management tool, but we could also, simply use an HTTP API for that. And that was already the introduction. And now we talk about Kubernetes secrets and the Kube API, which is also kind of a secret management tool, right? You can store secrets in it. And there is a Kubernetes object for that is meant to contain sensitive information. So you have config maps where you can put basically anything, and then you have secrets that have a dedicated purpose. It's a dedicated object where you can then build your RBAC upon, so that you make sure that only the right people or right service accounts like machine users have access to that sensitive data. It's persisted in the Kubernetes API, and workloads typically consume it via Kubernetes secrets, either via mounting them as volume mount or via environment variables. Now, there are already two things to consider when you consume them. Like one is, for example, environment variables. If you rotate your secret, they wouldn't get updated, so you would need to restart your pod in order to get this refreshed environment variable loaded. Or other option would be to mount it as an environment, as a volume, and then it would get updated. Only if you're not using subpath. If you use subpath, you won't see an update either. If you want to read about it, it's in the documentation, but I would consider this as a real common pitfall, and so just be cautious about it. Of course, additionally, what's really important is you need to know that by default etcd, so the backing storage of Kube API is not encrypted. So if you want to see encryption at rest, you definitely need to encrypt it. There are encryption configurations via Kube API available, so you can encrypt it and integrate the key from some KMS from the cloud, for example, to have some more durable storage for the key, for the encryption, and the storage then encrypted in etcd on locally. How does this typically look? How do you generate a secret? Well, there is kubectl create secret. Then you can choose a type of secret. Typically, you have generic or Docker registry, whatever you want to create. And you can create it from literal, from a file, and then the information will just get base64 encoded, which is no encryption. So it's just another form of data representation, really, like JSON, for example. And yeah, so far so good. So we've just talked about what a secret management solution should look like, what key points it should cover, and also we talked about Kubernetes secrets and what they are really. So let's now talk maybe about secret management and try to get an understanding of what we are actually trying to achieve when we're talking about secret management and what should be the ultimate goal there. So here I have some statements for you, which maybe are only personal, but I think everybody can relate to them typically. So secret management is generally a complex topic. And this is simply because the nature is or comes from security perspective. Security related things are always hard because they're kind of a black box. You simply don't know what vulnerability is waiting for you tomorrow. It's tricky. You don't know what to protect against or how to prevent the situation even happening. Now, Kubernetes secrets, on the other hand, are pretty simple. The concept is easy to grasp, but are they a holistic solution? Well, actually, it depends on your use case, right? If you use, for example, something like K8s Secrets, which is a kind of GitOps approach where you encrypt your secret in Git, so it's not readable no matter if the person has access to that Git repository or not, and it gets decrypted from within the cluster. The key for the encryption is, of course, placed in the cluster, and when you encrypt it originally before committing it to your Git, you interact with that key as well. But these solutions typically don't scale that well because you would need to replicate that key or somehow manage the encryption key in order to really have a smooth experience when you, for example, manage 50 or 60 clusters. I don't know how many you really manage. Hope not too many. And that's why we also see alternative solutions which act as a central storage for secrets, like HashiCorp Vault, for example. They add functionality like this central aspect, which I said, but also they have sometimes a UI, they have proper mechanisms in place like integrations for Kubernetes so to really easily and securely distribute the secret. Now I said easily together with HashiCorp integration Kubernetes in one sentence, which is maybe not true. I don't know if you've ever experienced, but we'll talk later about HashiCorp anyway. Yeah, as said, they add complexity in terms of secret consumption and security because it's just more parts that you add to the equation, right? Like maybe the operator vault itself, you need to protect them again. It's not only the kube API anymore, which you can maybe protect with RBAC, like Kubernetes RBAC only, and encrypt your etcd. No, it becomes definitely more. And simple this bigger attack surface, how I would call it, just makes it again trickier to protect and to come up with a reasonable strategy. So yeah, definitely all solutions have the trade-offs. And that said, I think for you to decide on what you should actually aim for, like should it be a simple solution like K8s Secrets, or should I only like directly imperatively create my secrets via kubectl, or should I use HashiCorp Vault, which is maybe the best solution that you can use in a cloud for a cloud agnostic strategy? Well, that's up to you. And I think you should know your requirements, like business requirements maybe, but also you should understand potential threats. And then from that perspective, we should then, decide for what we want to go for. And yeah, that being said, like quickly have a look on the Kubernetes secrets. By the way, if you've scanned my QR code initially, I've also links there and 2 must reads, which are mostly around this slide, and like feel really free to read it. They are fantastic written, and it's really eye-opening, at least from my perspective, in terms of how you should decide or how one should generally decide for the strategy there. So a Kubernetes secret, for example, it can be read via Kubernetes API. It requires, of course, some respective RBAC permissions. So if you, for example, have an exploit going on and the attacker is able to get a service account with the right permissions, he could read secrets directly from the kube API. Kubelet config typically also can read secrets only for the respective node, but still you could, when the attacker gains access to the node, he could imitate the kubelet and ask for some secrets. Now also, when the attacker is able to land on the control plane node, he could directly access etcd or its memory, both possible. And finally, generally, once there is an exploit going on in the pod directly, nobody can really prevent somebody from reading from memory. So this is generally really tricky to protect from, and therefore the attacker would need node access. There are tools like Python scripts to extract passwords from memory. During my research, I came across them, and I also shared them in the resources. Now, alternatively, we can use something like Vault and external storage central, but still we would have same problems like someone could imitate the pod with the right annotation and then get access to our storage and read the secrets from there. So really nothing different, but maybe Vault is somehow harder to operate and also kind of same hard to protect. Now, etcd, I have it crossed through here because, etcd won't play any role for secret management here because we keep the secrets out of kube API. And lastly, there's the same read from memory, of course, is still possible if somebody gains access to that. Now, before we go on and check what we can do to really mitigate those risks, I want to really put a caution here on this slide because this list is for sure not complete. This is tough work. I think there are many security specialists working on that topic. I'm not a security specialist. I'm a solution architect. Not that I'm not knowledgeable on it, but I just want to really emphasize here, don't take this list as complete. Okay, so yeah, Martin, that's scary. What should I do? Someone somewhere asking this question. Well, I think we need to take step by step and come up with a proper strategy. So first, I think we should identify the risks and think about what could potentially happen. It's really writing down things. And if you are working in a security team or in a team that does the ops for a cluster, just do some brainstorming together, and I'm pretty sure you will come up with a lot of things. So, for example, improper RBAC permission, like hacking attack via CVE, many more, of course, possible. Then how can we mitigate them? Some of them you will be able to prevent by preventive mechanisms, like, for example, policy engines as OPA gatekeeper. But some of them you will maybe only see when they are already happening, right? Of course, you could scan all your images and everything, but there you would only find the CVEs that are already known. You won't find those which are not in the vulnerability database. And therefore, you should then use tools like intrusion detection systems. For example, Falco is a pretty popular tool there, which is eBPF based, and it would give you insights, for example, you could build an alerting platform on top of it, which would tell you when there is, for example, a shell spawned within a container. And this way you can still stay proactive, even though you're probably already being hacked, but you would know about it and could act on it potentially. So, but still, is that enough? Is that now enough that you say, I did my job well? And I would not hardly argue, but I argue no. So you need to have processes in place for specific situations. So what to do when, for example, there is an exploit going on in cluster A. You need to know, should I seal my vault? How can I remediate from it? How can I just go out or escape that bad situation? And I think the more processes and the more detailed you really phrase them, the better, because it's a stressful situation, right? And you want to just simply read kind of a checklist what you need to do in order to just make sure that this doesn't happen again. Now, if this happens in production, this won't be easy. Typically, many applications consume many secrets, and that's a lot of work. So yeah, that's security, unfortunately. Yeah. And with that, now from the strategy, so what you should bear in mind when looking out for a solution like HashiCorp Vault or maybe only Kubernetes plain secrets, let's now talk about HashiCorp Vault and what it brings to the table. It's, from a top level perspective, a cloud agnostic open source secret management solution, which generally has many advantages. Like, it's a holistic solution. I can tell you, I just put the check marks here because it actually checks all the check marks for the key points. If you remember earlier on my slide, it can be operated on Kubernetes, which I really appreciate because I like Kubernetes very much. Not as much as my wife, if she watches. Yeah, it has support for various static and dynamic secret engines, so you can also do secret rotation automatically, like build your PKI public key infrastructure with it. So all that is possible with Vault, a real central component. So if you bet on it, you better bet good on it. And of course, it also offers Kubernetes integrations. At the moment, it's called Agent Sidecar and CSI Provider, both very sophisticated solutions, not so easy to configure, to be honest. Like, they are really intrusive, if you can say that, like in terms of like you need to add a lot of configuration to your manifests typically. Yeah, but now new Agent Sidecar, CSI Provider. Like, Agent Sidecar is something that actually provides the secrets and in shared memory. CSI Provider, as the name suggests, provides the secret in a volume to the consuming pod, or actually container. And now Vault really closes the gap with also bringing support for Kubernetes secrets with its new secret operator. And at the moment, this is in public beta, and I read about it. I've also seen in the documentation that there are other auth methods supported, but for now, officially, I read that only Kubernetes auth is supported. It, as said, closes the gap towards Kubernetes secrets, which previously was kind of a no-go when you were working with HashiCorp Vault. You would typically have used external secrets operator, for example, to bring your secrets to the Kubernetes API, or like things like CSI secret store driver back and then mirror the secrets that the secret store driver consumes to the Kubernetes API. Both have the drawbacks. ESO, like external secrets operator, for example, didn't support dynamic secrets, and the CSI secret store driver, for example, like the mirroring approach, I don't know. I always felt it was like abusing it when I was actually doing this, because unfortunately not every application is able to consume a secret from a file. Like, and this is the biggest problem. And I think that's why also they come up with a secret operator now by themselves, like HashiCorp. It can be installed via Helm or customize. That's great, of course. And yeah, it works with custom resources. So cloud native, Kubernetes native. Yeah, taking now a step back, I don't know how carefully you've read the description of this event, but I want to address this openly. So, and I will address this topic, but not in the detail I hope that you maybe expect this. So, talking about running Vault in production in Kubernetes. So what you should consider there is, of course, you should always operate it in its own cluster. For production, definitely. Don't share the cluster with any other application. This is simply like, it would be maybe a waste of resources, but you wouldn't like to do this. In case of an incident, you will regret it forever. At least maybe share it, give it its own node pool so that there is nothing else running on it, except other critical workloads, which make your Kubernetes cluster work, of course. You spread the Vault pods using topology spread constraints or pod anti-affinity, whatever you want to use, in order to really make sure that they distribute across your availability zones in Kubernetes. Yeah, configure a highly available storage backend like Consul or Raft. I guess that's kind of straightforward, but important here, this is not everything. Of course, you should also use storage, like the underlying storage, not talking about that, that is able to be attached to a different node. Because why is that? If you have node failure, for example, and your Vault pod gets rescheduled to another node, well, you want to rebind that volume there. And if the volume is bound to a specific node, you cannot, and you would just simply lose your AJ setup potentially. Yeah, use sophisticated auth methods like OIDC or JWT tokens. App role, of course, you can also use it if there is no other way around it, but I would always recommend solutions like OIDC because, first of all, they work really nicely with like dynamic policies involved, so you don't need to write too many policies. And additionally, like from my perspective, they're just more secure because they work with kind of, how to say this, with validating the token that you anyway have. So they kind of solve also the secret zero problem. Because in Kubernetes, right, you can use, for example, a service account token, which is a JWT token already. And you just tell Vault how to authenticate it, how to verify that token is actually the token from your Kubernetes cluster. And then you would have access to it without putting a secret that has the password and credentials for Vault into the cluster. Yeah, enable TLS when you deploy the Vault. And very important now, if you want to see a dedicated session on this, so only production grade deployment, no Vault secrets operator, let me know in the chat, please. And we can have a follow-up session on this, building up on the knowledge from today. And we can see how I would deploy Vault on a production grade setup, like everything on that list checked. And then we can just have fun with HashiCorp Vault. And that's it. We are going to jump to the demo right now. What will the demo look like today? So I have a Minikube cluster prepared today with Vault running already with 3 replicas, with Vault secrets operator in its own namespace. And also I have an app namespace, which I run my app in. It's called my app as well. It doesn't do much. It's actually a BusyBox image, and it wants to consume a secret. And I want to bring that secret there with the Vault secrets operator. Now, yeah, that's the architecture. And with that, I now will switch over to my terminal. This is not my terminal, actually. This is rather my VS Code. So I mentioned earlier that Vault actually uses custom resources to work on Kubernetes. Now I will quickly show you on what is actually running in my cluster so that you get an idea of it. So as you can see, we have the Vault secrets operator running in the Vault secrets operator namespace, and we have 3 instances of Vault running in the Vault namespace, and also Vault agent injector, which we are not going to use for our cluster. That's the setup. And let's now check how this really works. How do I need to configure my HashiCorp Vault secrets operator in order to bring secrets to my cluster? And the first point is tell the secrets operator where it can connect to the HashiCorp Vault API. And as it's running in the same cluster, it goes to Vault service cluster local. As you can see, I'm not running this encrypted in TLS mode. Of course, in production, you should definitely do this. For the sake of this demo, and also for you, if you want to get your hands on this, I have some materials online that you can really easily replicate this in your own Minikube cluster without having to, hustle with the TLS certificates and stuff. So that's it. When you want to apply, you can simply apply this with, I will type it, kubectl apply -f. And let's apply the connection. Now this won't do much, right? Because we can't authenticate. So there is no authentication information, not really. So we need to check also for the authentication. The authentication is, in this case, really simple, and I also mentioned it. I've used the Kubernetes auth method for connecting. First, it's the only publicly, not publicly, but it's stated that this is the only auth method currently supported by the Vault Secrets operator. So I've used it and I've configured it already. If you want to see how this works, again, I've linked the official HashiCorp tutorial on that online in my resources, so you can really get easily to the place where I'm starting right now. Yeah, and this is the authentication information. So as you can see here, I'm saying it's Kubernetes auth. I've mounted the auth under Kubernetes/local because it's the local cluster in case I use this more often, like the Kubernetes auth. I want to have this kind of namespace approach, so I can do, for example, Kubernetes/production cluster, Kubernetes/staging, and so on. So I can connect the clusters if I want to use the Kubernetes authentication. I also provide in the role that the Vault operator, the Vault Secrets operator should inherit when he tries to retrieve the secrets, and what service account it uses for that. Because service account, remember, holds the token that in the end will be verified via the review token API. So this is how Kubernetes method works, Kubernetes auth method works. So let's apply that as well. I will now do kub for kubectl apply file and off. Now that's good. Let's quickly check what that does. kubectl describe, and we will check first the Vault connection, and let's just quickly check what it gives us. And it just says in the event section, I'm reading right here, Vault connection accepted. So guess it didn't do much. The status also shows valid true, so I guess that's okay. Now we will also check quickly the auth, whether this gives us more information. And when we check that as well, it also says accepted, successfully handled Vault auth resource request, and the status is also valid and true. So looks good. And before we now go on, I want to show you the namespace of my app actually, because we don't know if something is running there, right? Maybe I'm faking this. So let's check for the pods. So there are no pods, and kubectl gets secrets. Also no secrets. So everything fine. So finally, let's have a look on our secret resource. It's called Vault Static Secret, the kind of the CR from Vault. There is also something for dynamic and for public key infrastructure, for certificates. So you have dedicated kinds of resources or objects that you can use to actually sync from your Vault instance. So in that case, it's a static secret. So it's easy as that. I just created a key value store of version 2, which has an API token in it. I can quickly show that. Let's maybe do that because maybe this becomes more clear and you will also see the UI. So this is the Vault UI. I'm using the root token now, also very important. If you use the root token and still have a root token in production, you should not do this. When you set it up in production, the first thing you should do, disable it. Disable the token authentication. So, okay, in secret, we actually have my app. And here we have the config, which holds the API token. It's nothing fancy. It's just holding foo-bar. So if you're a developer, I guess you're familiar with that. Typically key value property naming. And yeah, that's my API token, which I will hold in the configuration and what we want to supply our application with. So now switching over again to our terminal really, because now I will switch to the terminal and the port forwarding. And now we are going to apply the secret, okay? And the secret, as said, it is a key value store of version 2. It's mounted under the base path of secret. And then we go deeper, my app/config. You've seen it when I just traversed through the tree. Actually, what I really consider to be nice about HashiCorp Vault compared to the cloud solutions is actually this namespacing, that you can really like kind of navigate down in a directory and put your configuration wherever you want it. This is really nice about Vault. And I was heavily working, for example, with Azure Key Vault. I didn't have the same experience there. And yeah, also the policy engine on HashiCorp, it's neat, but it takes some time to learn it. So, but I think it pays off at the end of the day. So let's apply the secret as well. And now let's watch kubectl. Get secrets. And 8 seconds ago, it got synced already, so pretty fast. Of course, the operator gets notified as soon as there is a new custom resource being added where it watches for. So that's why. And let's now check out what that secret really is about. Secrets config -o YAML. Oh, let's make this bigger maybe because I don't know if you're able to see it. So this is my secret. Here is the API token, so it looks promising. And if we do echo and base 64 encode this, we should see foobar. Voila. And this is already, this is like how we could bring it to the Kubernetes API. Now, I know that we are already over time, but I want to show you something else because I mentioned this with Kubernetes API, with how you consume secrets with an environment variable and stuff. Maybe this is interesting to you. We can go a bit further on that. And I still want to emphasize, we have a Q&A feature here. So if you have some questions, please drop your questions into the Q&A feature of Zoom, and I would be happy to answer your questions no matter what, really. And yeah, with that said, I'm happy to see still so many of you with me, so don't drop off. I am going to show you something regarding how secrets can be consumed in a deployment and what's actually the difference between consuming them via a mounted volume, and, for example, environment variable. Let's check this deployment here. I will quickly highlight where you should pay attention to because I know it already. So I said this is a busybox image, which doesn't do anything. And here I mount the secret config with the key API token, which we've just explored, to the environment variable API token. Also, I mount the volume, where I also mount the secret as a config. I just use one deployment for all the 3 scenarios that I want to show. Now, environment variable is one scenario, and the 2 other scenarios are using a mount without a subpath and one with the subpath. Remember, I said when you use a subpath in a container, it won't get updated by Kubernetes nature. This has nothing to do with the Vault secrets operator. This is just how Kubernetes works. This is also part of official Kubernetes documentation. It mentions that when you use subpath, it's not possible to get your secret updated. Why subpath is actually there is because when you place, for example, your secret into a specific folder, like in this case, at c/my_app, it would wipe the whole folder and just put API token file in there. Only if you use subpath, it would keep all the files and add the API token file. But you see already, you would have a trade-off, namely, you wouldn't get the update. So that's it actually, and that's what we're going to explore now. So let's apply the deployment. Okay, the pods are coming up. Cool. So let's have a quick look into the pod. Okay. And let's not do quickly env. Like this is also like very simple. If you are a hacker, the first thing you run in a Kubernetes pod where you land is env. Because typically when you mount a secret with environment variables, you would spot it. And here we have our API token already. So pretty simple, right? That's why also mounting secrets or using secrets by environment variables not really recommended. Rather, like if possible, if your application takes a file, like use it. And then we also check cat at c, my app, and here we have API token as well. And it gives us foobar. And what we also have is subpath API token. We also have it here. Now, I will quickly move over to the to our Chrome again, to my Chrome. So here we can create now a new version for that secret, and we will just do changed. Switching back, we see now that the API token is still the same as before, and now we are going to wait until Vault picks up the change and syncs it again. And it changed. See? So let's check what this means. Echo base 64D, and it says changed. Now, what does this now mean for our application, right? So again, let's quickly execute into it and check it again. So we do env first, and we see API token is still foobar. Now we do cut. Let's see. My app, API token, and it's still foobar. And this takes some time. At least when I was trying the demo. Let's wait a bit. This takes a time until it's updated, but trust me, this will come. I'm confident. So this is also foobar still. As said, it takes some time until this, and trust me, I didn't change it manually now with another terminal console like in the background. So you can also try this. I will put this up on GitHub so you can really replicate this. And this is changed. And comparing it now to the subpath, really, to the subpath 1, you will see that the subpath is not updated. And this is important to know. So it's still foobar. So environment variable and subpath mounted secrets are not being updated, while only the plain volume mount is updated. Now, finally, and this is really the last thing I want to share today, is there is an option in the secret where you can actually make your application restart. So you can, for example, here, and I will uncomment this now, do something like a rollout restart target. And when Vault operator sees the secret being updated, it will just do a restart, a rollout restart. There is kubectl rollout restart on the deployment. My app, it will restart it, so the pods get recycled and they get the new environment, the new fresh environment variable, or the new fresh mounted subpath volume. So this way you could actually work around this. But of course, this means that Vault operator is restarting your application. I don't know if you want this. If yes, well, that's up to you. I don't know. I personally, I have my doubts about it, let's say. But it doesn't do any harm. Like restarting typically doesn't do any harm. And yeah, with that said, this was actually everything that I've prepared today. I hope you really liked it. I don't see many messages in chat, but I was asking if you really want to see another session on HashiCorp Vault and how to run it in production with that list that I've mentioned earlier. Like, please let me know and we can do another session on it. And if not, really happy to have you. Hope it was interesting and hope you learned something from today's session.